Now think about this. The internet is a vast, sprawling city, absolutely chock-a-block with amazing places to visit, websites, online games, video streaming services, you name it. But how does your computer, your trusty digital explorer, find its way to, say, bbc.co.uk or your favorite cat video emporium? It doesn't magically know where these places are located in the digital ether. It needs a map, or even better, a super efficient address book. That, my friends, is precisely what the domain name system, or DNS, is. It's the internet's unsung hero, working tirelessly behind the scenes, making sure you get where you want to go online without a fuss. Imagine trying to phone all your mates, but instead of their names, you had to remember everyone's unique, long-winded phone number. You'd need a colossal memory, wouldn't you? Was that 07700900345 or 07700900354? It would be a right kerfuffle. Humans are brilliant with names like Auntie Jean or Big Bob's Bikes, but we're a bit rubbish at remembering long strings of digits. Computers, on the other hand, are absolute wizards with numbers, but don't really get names in the same way we do. They prefer precise numerical addresses to find each other on the internet's massive network. So, the basic purpose of DNS is to act as a translator. It takes the human-friendly website names we type into our web browsers, called domain names, and translates them into computer-friendly numerical addresses, known as IP addresses. Think of it like this. You tell your taxi driver you want to go to Buckingham Palace. That's the domain name. And the driver, using their knowledge or a map, which is like the DNS, figures out the exact street address or the IP address to get you there. Without DNS, navigating the internet would be like trying to find a specific house in London with only a vague description and no street names or numbers. Practically impossible. This translation service is utterly fundamental to how we experience the internet every single day. Every time you click a link, send an email, or watch a video online, DNS is likely involved, quietly doing its crucial job. It's one of those brilliant inventions that's so effective and integrated into the fabric of the internet that most people don't even realize it's there, working its magic. But without it, the internet as we know it simply wouldn't function. It's the digital signpost, the grand central station of internet addresses all rolled into one. Science? Alright, let's break down the main players in this DNS spectacular. First up, we have domain names. These are the easy-to-remember addresses for websites like google.com or wikipedia.org. Think of them as the shop's name on the high street, something catchy and recognizable that tells you what you might find there. They're designed for us humans, making it simple to recall and share web locations. Instead of a string of baffling numbers, you just need the name. It's a much more civilized way to browse the web, wouldn't you agree? These names are structured, often with parts like .com, .co.uk, or .org, telling you a bit about the website's nature or location. Next, we have the famous IP addresses. IP stands for Internet Protocol, and an IP address is a unique numerical label assigned to each device connected to a computer network that uses the Internet Protocol for communication. For example, 192.0.2.146 could be an IP address. This is the actual phone number or postal code that computers use to find each other. Whilst you type scienceftw.com, your computer needs to find the numerical IP address associated with that friendly name. There are two main types currently, IPv4, which are a series of 4 numbers separated by dots, and the newer, much longer IPv6 addresses, designed because we were running out of IPv4 ones. Then come the DNS servers. These are the actual phone books, or more accurately, powerful computers that store all these domain names and their corresponding IP addresses. There isn't just one giant DNS server for the whole world. That would be terribly inefficient and a single point of failure. Instead, there's a whole hierarchy of them, spread across the globe. Some are like local directories, whilst others are like massive national or international encyclopedias of addresses. When your computer needs an IP address, it asks one of these servers, and they help to find the correct information, sometimes by asking other DNS servers in the chain. Finally, we have the DNS resolvers. Often your internet service provider, the company that gives you your internet connection, provides a DNS resolver. You can also use public resolvers like those from Google or Cloudflare. Think of the resolver as a helpful librarian or a very determined detective. When you type a website address into your browser, your computer first asks its configured DNS resolver to find the IP address. The resolver then does all the legwork, querying other DNS servers across the internet until it finds the correct IP address and returns it to your computer. It's your personal internet address lookup assistant. So, you're ready to visit a new website, perhaps one about the amazing world of quantum physics. You type its domain name, let's say superparticles.org, into your web browser and hit enter. What happens next is a fascinating super-fast journey. Step 1 is your browser and operating system checking their own little caches, a sort of short-term memory. If you visited superparticles.org recently, the IP address might already be stored locally, and bingo, you're off. This makes repeated visits much quicker, which is rather clever. But let's say it's a brand new site for you. Step 2 involves your computer sending a query to its configured DNS resolver. This resolver is usually provided by your internet service provider, or you might have set up a public one like Google's, which is 8.8.8.8, or Cloudflare's, which is 1.1.1.1. The resolver first checks its cache. If another user of that resolver recently looked up superparticles.org, the IP address will be there, and it sends it straight back to your computer. Efficiency is key in the digital world, you see. If the resolver doesn't have the answer in its cache, that's step 3. It begins a more extensive search by contacting one of the root DNS servers. There are only 13 sets of these root servers strategically placed around the world, acting as the main index for the internet. The root server doesn't know the IP address for superparticles.org itself, but it knows where to find the servers that manage all .org addresses. So, for step 4, the root server directs your resolver to the appropriate top-level domain server, in this case, the TLD server for .org domains. Now at step 5, your resolver queries the .org TLD server. This TLD server still might not have the specific IP address for superparticles.org, but it does know which authoritative name server is responsible for that particular domain. Think of authoritative servers as the ultimate source of truth for a specific domain, managed by the domain owner or their hosting provider. So for step 6, the TLD server points your resolver to the authoritative name server for superparticles.org. Your resolver then asks this authoritative server, which finally provides the precious IP address in step 7. The resolver then passes this IP address back to your computer. And for step 8, your browser uses this IP address to connect directly to the web server hosting superparticles.org, and the web page begins to load. Phew, all in a fraction of a second. We've touched on it, but let's really delve into DNS caching. It's kind of like your computer or the DNS resolver having a brilliant short-term memory. When a DNS lookup happens successfully, the resolver, and often your own computer's operating system and browser, will store that domain name to IP address mapping for a certain period. This is caching. The next time you, or someone else using the same resolver, wants to visit that same website, the system can just grab the IP address from its memory cache instead of going through that whole multi-step lookup process again. This makes web browsing significantly faster, especially for frequently visited sites. This stored information isn't kept forever though. That would be problematic if a website changed its IP address. Each DNS record comes with something called a time to live, or TTL, value. The TTL is set by the owner of the domain and tells resolvers how long they should keep that specific piece of information in their cache. It could be anything from a few seconds to several days. Once the TTL expires, the resolver knows it needs to discard that cached information and perform a fresh lookup the next time that domain is requested, ensuring the information stays up to date. It's a clever balance between speed and accuracy. Now let's talk about keeping things safe and sound with DNSSEC, which stands for Domain Name System Security Extensions. The original DNS system was designed in a simpler time and didn't have robust security features built in. This meant it was potentially vulnerable to certain types of attacks, like DNS spoofing or cache poisoning, where naughty individuals could redirect you to a fake website by giving your computer a bogus IP address. Imagine typing in your bank's address and being sent to a convincing fake site designed to steal your login details. Yikes. That's not good at all, is it? DNSSEC helps to prevent these kinds of shenanigans by adding a layer of trust and authentication to DNS responses. It uses digital signatures to ensure that the DNS data you receive is actually from the stated source and hasn't been tampered with en route. Think of it as a digital wax seal on a letter, verifying its authenticity. When your resolver gets a DNSSEC protected response, it can check the signature. If the signature is valid, you can be much more confident that the IP address is genuine. It makes the internet a safer place for everyone to conduct their business and browse without undue worry. Sometimes even the most brilliant systems can have a hiccup, and DNS is no exception. You might have seen error messages like server not found, DNS server not responding, or websites just loading incredibly slowly. These can often be symptoms of a DNS-related problem. Perhaps your computer can't reach its configured DNS resolver, or the resolver itself is having a bit of a moment, or maybe there's an issue with the DNS records for the specific site you're trying to reach. It can be frustrating, but often the fixes are quite straightforward, so don't you worry. Before you panic, there are a few simple troubleshooting steps you can try. First, the classic check your internet connection. Are other devices online? Can you visit other websites? Sometimes it's as simple as a loose cable or your Wi-Fi needing a quick reconnect. Next, try restarting your router and modem. Just like restarting your computer can fix many glitches, power cycling your network equipment often clears up temporary DNS communication issues. It gives them a fresh start, which can sometimes be all that's needed to get things flowing smoothly again. If those don't do the trick, you can try flushing the DNS cache on your computer. Your operating system keeps its own local cache of DNS lookups, and sometimes this can become corrupted or outdated. Flushing it clears out this local memory, forcing your computer to perform fresh lookups. The command for this varies by operating system, like for example on Windows. As a slightly more advanced step, you could also try changing your computer's DNS server settings to use a well-regarded public DNS resolver like Google Public DNS 8.8.8.8 and 8.8.4.4, or Cloudflare 1.1.1.1 and 1.0.0.1. Sometimes your ISP's default DNS servers might be slow or experiencing temporary problems. So, there you have it. The domain name system in a nutshell. It's this incredible globally distributed database that works silently, day and night, translating the website names we use into the numerical IP addresses computers need. From the initial query to the final connection, through root servers, TLD servers, and authoritative servers, with caching speeding things up and DNSSEC keeping things secure, it's a truly remarkable feat of engineering. Without DNS, our intuitive name-based internet simply wouldn't exist. It's one of the fundamental building blocks that keeps the World Wide Web spinning smoothly for billions of us. Isn't science and the internet just fantastic?